Well, hello guys, here Mr. G with another video. We are going to be solving a question on vertical projectile motion, and this one was question 3 from the Eastern Cape province, done in September 2023. I will leave the question in the description below so you can answer before watching the video, and don't forget to subscribe to the channel so you can get all the notifications and videos I post on a regular basis. This question says two identical objects A and B are projected vertically upward from the ground 0,04 seconds apart. It means they throw one object, guys, and then 0,04 seconds after they throw the other object. Object A has an initial velocity v and object B has an initial velocity of 11,025 meters per second. So let's probably write it here as an important data. Initial velocity A is equal to v, and initial velocity B is equal to 11,025 meters per second. Okay, and both of them were up. Okay, that is important data. Now, after both objects are released, the motion can be described as free fall. The motion of the object is presented on the following position times graph, and you have a position time graph there. For object A, for instance, velocity, the initial velocity of object A is v, but you can see that the total time it takes to reach the ground is 1,5 seconds. And object B is released 0,04 seconds after object A and is at this specific point after 1,5 seconds. That is what you can see in the graph. You do not know the position, so you don't know what is the maximum height of any of them. You don't know that. Question 3.1, define the term free fall. And guys, there are only two definitions in projectile. One of them is free fall and the other one is projectile, and both of them are more or less the same. For free fall, is a motion during which the only force acting on the object is gravitational force. So only force acting is gravitational force. If you say that, you will get the 2 mark. It's very easy definition. Question 3.2, if object A takes 1,5 seconds to return to the ground, prove that the object was projected upward with an initial velocity of 7,35 meters per second. Okay, so what we need to know for this specific question. Let's solve that question here, and let's write here data really fast. Initial velocity is going to be proven to be 35 meters per second. This one is to be proven, so we cannot use that data. If we take the time, the total time is equal to 1,5 seconds. Now, does it mean that the time to go up is equal to the time to go down, which is equal to 1,5 divided by 2, and that is 0,75. Now, this is the time to go up as well as the time to go down. What else do we know? The acceleration due to gravity is 9,8 meters per second square down. All right. So, I'm not going to even write down here. I'm going to keep it just like that, meters per second, and I'm going to write direction on top. I'm going to write here, for instance, down positive. Therefore, the acceleration due to gravity is positive. This one I'm leaving because I'm looking for it, guys. Okay, so let's go to take, for instance, the motion up. So I'm going to write here motion up. If the motion is up, the maximum height or the velocity, the final velocity, which is at maximum height, is equal to 0. That is important. Okay, so we are going to write the formulas on this side. Now, what formula can we use? Very easy. Final velocity is equal to initial velocity plus acceleration multiplied by the time. Okay, now here are the formulas. Here are the formulas, and this one here are the formulas you are going to be using in projectile. So all the formulas are there, and the first one is the one we are going to be using here. So we are here, final velocity 0, initial velocity, we are looking for it, please don't forget that one, acceleration due to gravity is positive because I say down is positive. Okay, so this one is 9,8 multiplied by the time, which is 0,75. Okay, when you do this one, you get that 0 is equal to initial velocity plus 7,35, and when you rearrange, you get that initial velocity is equal to minus 7,35 meters per second. Note the following: if you look here, I say down is positive, therefore this negative means that is up. So the initial velocity is, let's write it properly, the initial velocity is equal to 7,35 meters per second upward, and that is the final answer. We have proven that is the same. If you do this one, you'll get 2 marks, one for the formula and one for the substitution. The answer doesn't get marked because at the end is the same answer. Now, question 3.3, calculate the maximum height of object B above the ground. Okay, so here we are, we want to work for object B. What do we know about object B that really is important for this question? First of all, we have that the initial velocity is equal to, and in this question we can take up as positive. Up positive, please. Let's do this one always when we begin the data. So we can say here now, for instance, initial velocity is positive 11,025 meters per second. Okay, that is important. What else we know? Acceleration due to gravity is equal to minus 9,8 meters per second square. Okay, we're looking for the height. In this case, it's going to be the displacement, if we may. All right, we have that the velocity final, which is at maximum height, is equal to 0. Okay, because we're looking for the velocity at the maximum height, and you need to know that if the object is being projected upward with an initial velocity, when it reaches the maximum height, if this is h maximum, the velocity there is equal to 0. You need to know that. Okay, the initial velocity, you know, is given to you. All right, so guys, now the formula, you go to the formula sheet as usual. Here is the formulas, and know the following: we do not have time, so it cannot be any formula with time because we don't know how long it took to reach the maximum height, and we cannot divide 1,5 because in 1,5 did not reach the ground, it reached there, so we cannot use this 1,5. Please note that one. So we cannot say that this 1,5 because 1,5 did not reach the ground. We cannot divide it in 2 parts. Okay, so in other words, in this work we don't have time. All right, so what formula is helping us without time? Well, it's this one here. This formula here will help us with no time. So let's write the formula here exactly in the same way as it is there. There we go, to acceleration multiplied by the displacement. This displacement in this case will represent the maximum height. This one here will be the maximum height we are looking for. That is the displacement here. Now, if you substitute here, it's quite simple. This one is 0 square is equal to 11, is positive 11,025 square plus 2 multiplied by minus 9,8 displacement. Be careful, don't you forget the minus here. So this one is important, guys. Do not forget that one there. And well, the rest is just calculation. So you will get that this one is equal to positive 6,20 meters, and that one is the maximum height for object B, is 6,2 meters. That is the answer, guys. Now, if you do this one, this is the answer, eh? If you do that, what you get? You get 1 for the formula, 1 for the substitution, and 1 for the final answer. And it's quite easy, guys. It's not difficult. Question 3.4. As object B falls back to ground, it lands on a roof. That is why you can see that doesn't reach the ground there. It falls on the roof of a house at the exact same time that object A. So in other words, in this point here, what you see is the roof of a house. This is a roof. Okay, this one is the roof at this specific point. Okay, now what the aids they say at the same time, calculate the height of the roof. Okay guys, so this one is going to be question 3.4, and let's try to picture here what is actually happened so you understand. This ball is thrown upward. Okay, let's say for instance we have here this is the floor and here is the house with the roof, for example, just for you to get an idea of what is happening here. This ball was thrown straight upward. This was not thrown horizontally. Okay, so it was thrown upward. It was moved up, okay, with an initial velocity which we know, and let's also write it here. It was 11,025 meters per second. This ball is thrown up. It moved up straight up, and on the way down, because it moved, yes, it's very tiny side to the right, it fall on the roof. Okay, it fall on the roof. The ball that was using a black color for the ball falls there and stays there. So this is what happened here. The ball was thrown upward with a velocity of 11,025 and eventually falls there. Now, when does the object falls there? It did fall. If we go to the graph, it count of 1,5, but remember this ball was not thrown exactly with ball A. So time B will be equal to time A minus 0, let me show you here, minus 0,04, because it was thrown 0,04 seconds later. So it was minus 0,04. So time B, for example, will be 1,5 minus 0,04, and that is equal to 1,46. This is the time for B to reach that roof. Okay, that is important. Now that is the first important thing I want to point out, but there is something else. They want to know the height of the roof. Now if we come back here, the initial position, and now I'm speaking about position. The initial position is the ground. This one is when the object was first. That is what we call initial position. And the final position is the top of the roof, which is where the objects land. That is the final position. Okay, we're speaking about position. This one is position, and that is done in grade 10s, guys, in grade 10s. What is the displacement of the object? The displacement of the object is a vector that is going from the initial position to the final position. This one here is the displacement of that object. Okay, the displacement of the object, and we have formulas to calculate the displacement there. We have formulas to calculate displacement, and that is what we are going to be using here. I just wanted to point out that in actual fact, this height of the building is the displacement. Now we do have the time and we have the initial velocity. We don't have the final velocity. So in this case, we have to use a formula that does have time, but it does not have final velocity. So this is practically the data we have. The only thing we have here is g, which is equal to 9,8 meters per second square. And now for this question is entirely up to you again. But let's say up is positive. Let's highlight it here. It's important to know that one. And what formula are we going to use? I'm not going to the formulas anymore. You can go there. The formula here will be displacement equal to initial velocity multiplied by the time plus half acceleration multiplied by the time square. And when you substitute here, remember up is positive, therefore the acceleration due to gravity here is negative. So you will have that the displacement is equal to 11,025 multiplied by the time. You know, there is not going to be enough space here, so let's do it at the bottom. Let's leave the formula there, so you know, and let's do the substitution here. There we go. So let's do all the substitution. Multiply by the time, which is 1,46 plus half acceleration due to gravity is minus 9,8 multiplied by the time square, which is 1,46 square, and the rest is calculation. Do we get that the displacement is the height of the building and is equal to 6,65 meters? That is the answer for this question. If you do that, guys, you will get 1 mark for the formula, 1 mark for the substitution, 1 mark for the final answer. It's not that complicated. The only thing I wanted to point out here in this picture is why is the displacement. Okay, so now let's go to the next question. And the next is the final one. Say determine the time at which the two objects are at exactly the same height above the ground. So they want to calculate the time when the objects are, let's say for instance, at this point here, where are the same time above the ground, or let's say the same height above the ground. At that specific point, the two objects are at the same height from the ground. That is what they want you to calculate here. Now this one is question 3.5, and it's a tiny little bit tricky. Now what we need to know, that when they are at the same height from the ground, they have the same final position with respect to the ground. That is important. The same final position. We can say at that point that the final position A is equal to the final position B. That is important. It is very, very important. Now, how do we calculate position? Well, position is equal to initial position plus the displacement. Where is this coming from? Displacement is equal to the change in position, final minus initial, and then I rearrange there for the final position. Okay, so at a specific point when they are at the same height from the ground, what they actually have is the same final position. The initial position for both of them, the initial position A is equal to the initial position B and is equal to 0 because both of them were thrown from the ground. So in other words, the position, the final position, will be equal to the displacement. Alright, so I hope you understand this one. I'm explaining this one because not always both of them are thrown from the same height from the ground. Sometimes one of them is thrown from up, and then the initial position is not the same. So this is the approach. Please be careful with this one. So due to this fact, we can say that the displacement final A, no final, the displacement is not such thing as final. The displacement A is equal to displacement B. We're looking for time. So we need to write here or substitute the time. Let's see. Displacement, what formula can we use here? We don't have the velocity at that specific point. So we have to use a formula that only have the initial velocity. So we're going to say here that the initial velocity of A multiplied by the time A plus half acceleration due to gravity multiplied by the time A square. Let's do this one here. Let's do it with time, so you do with space so you can see it nicely. Let's say initial velocity multiplied by time A plus half multiplied by acceleration due to gravity multiplied by time A square is equal to initial velocity multiplied by time B plus half acceleration due to gravity time B square. square. Note everything that this on the left, all this one here is for ball A. This one is for A. Okay? And everything on this side here is for ball B. So please don't forget that one here. Now, what else we know? We know that time B is equal to time A minus 0,04 seconds. So that is time B. We know that time B is equal to time A minus 0,04. And that is what we must substitute. Remember, we did the calculation somewhere here. Just it's a different number. We don't have the number here, the actual number. Okay? So that is important to know. Let's substitute what we have in each of the cases here. And let's write here up is positive. We have all the data, guys. We are not going to rewrite the data here because we have it used in all the other questions. So here we have that the initial velocity is 7,35. This one was calculated in previous question. TA, I'm going to just write TA, okay? Plus half minus 9,8 multiplied by TA squared. All right. And on this side, we have that the initial velocity is 11. Let's quickly first move all this one all the way up here. Okay, so we can use that space there. So we have here, this one is 11,025 multiplied by TB plus half, same story, minus 9,8 multiplied by TB squared. And we are going to work a little bit now of what we have here. Okay, we are going to be substituting even more. So if we move on, we have 7,35 TA plus no, let's solve this side here quickly, minus 4,9 TA squared. All I did was divide 9,8 divided by 2, okay? And this one is equal to, let's move it here because we made it more space. Now here we have 11,025 TB. We are going to substitute the equation we have here on top. This one here, we're going to substitute it now. We're going to have everything in terms of TA. So this one is TA minus 0,04. All right, everything plus half. Let's solve that one. This one is going to be minus 4,9 bracket. Now this one is going to be TA minus 0,04 everything squared. So here let's carry on working. This one is 7,35 TA minus 4,9 TA squared. Everything now is in terms of TA equal to, now we have here 11,025 TA minus 0,441 minus 4,9, and then you have to solve this one here. And this is what we have. The rest is just mathematics, guys. So let's try to solve this one real fast, okay? And then the final answer will be 0,11 seconds. This is the final for the time. 0.11 seconds after ball A is being thrown is that the two balls will be at the same height from the ground. This one is the final answer. Now let me show you something. All these calculations from here down will have only one mark, which is actually the final mark. So guys, it takes long to do all that calculation. You manage your time wisely here. So let's give mark for this question here. To me, it took me a long time to do all that calculation. Now, where are the marks here? Let me look quickly. One for writing this formula, either right or left, it doesn't really matter. One for this substitution, one for this substitution here with a 0.04. It means this substitution get 1 mark. Okay, where is the other mark? There's another mark for substituting that one, I guess equating, and then is another mark for the final answer. What I'm saying, the final answer only carry 1 mark. But guys, this is all for this question. It was a little bit long, but that's it. I really hope it helped. If it helped, thumb up, subscribe for the channel. Next time we're going to be solving a question on a momentum, and don't miss that video. Thank you for watching. I'll see you next time. Mr. G here.